The topic is routing algorithms, in which we are going to cover the distance vector routing. Let's start with this. Uh, First, start with the routing algorithms. Routing is a process of establishing the routes that data packets must follow to reach the destination. In this process, a routing table is created which contains information regarding the routes which data packets follow. Various routing algorithms are used for the purpose of detecting which route and incoming data packets needs to be transmitted on to reach destination efficiently. So what is routing algorithms? We have the different algorithms. Why we make these routing algorithms? To define the routes between the different systems. However, whenever a system who wants to send the data to any system that is a part of a network, out of the different routes, they have to follow a particular route. We have the number of routes are there, and the routers, they have the complete information about the routes from each device to the other device. Classification of routing algorithms. The routing algorithms can be classified as follows. The routing algorithms, they are categorized into the two categories, the adaptive and non-adaptive. Let's start with the adaptive algorithms. These are the algorithms which change their routing decisions whenever network topology or traffic load changes. The change in the routing decisions are reflected in the topology as well as the traffic of the network, also known as dynamic routing. These make use of a dynamic information such as the current topology, load, delay, etc. to select the routes. Optimization parameters are distance, number of hoops, and estimated transit time. Now, this is the first category that is called adaptive routing. In the case of adaptive routing, this, the packets can change their routing decisions. And that why they change the routing decision, that depends upon the network topology and the particular load or the current load on that particular path. Suppose if the load is very high on that particular path, so automatically the packets, they can change their route from this particular route to the other route. Also, this is also known as the dynamic routing. The routes are given to the packets, but if there is a very jam on the route or the number of packets are very high, so automatically these packets can change their route and select an alternative route. All the algorithms that comes under this category, they known as the adaptive routing. And the second is non-adaptive routing. These are the algorithms which do not change their routing decisions once they have been selected. This is also known as the static routing, or the route to be taken is computed in advance and downloaded to routers when route is booted. So what it means, the algorithms that comes under the category of non-adaptive, they cannot change their route. Either how much traffic is there, what is the topology that is going to be on the route, but they have to follow the particular route. The route that is decided at the initial stage, all the packets, they can follow this particular routes, and all the algorithms that comes under this category, they are known as the non-adaptive algorithms. So we know what is routing algorithms. We have the two types of algorithms, adaptive and non-adaptive. Adaptive means the packets who changes their routes, that depends upon the network topology and the current load. They are come under the category of adaptive. And the packets who cannot change their route, the route that is decided on their headers, they are selected on this particular route, is called the non-adaptive algorithms. So the next is the distance vector routing. A distance vector routing, or you can say DVR protocol, requires that a route information, its neighbors of the topology changes periodically. Historically known as the old ARPANET routing algorithm, each router maintains a distance vector table containing the distance between itself and all the possible destination nodes. Distance based on the chosen metric are computed using the information from neighbors distance vectors. So how it works? Vector means basically vector mean a table. A name is distance vector routing. So what it means, a distance table is made by every host. A distance vector is mean, I just give you a simple example. Suppose a four system are interlinked with each other, A, B, C, and D. All these systems, they have the distance table. From A, you have a distance table that from A, how many far from B, C is how many far from A, and D, how many far from A. So like this, every system, they have a distance table from all other nodes. Clear? So the distance vector algorithm. A router transmits its distance vector to each of its neighbors in a routing packet. Each router receives and saves the most recent received distance vector from each of its neighbors. Uh, a router recalculates its distance vector when it recalculates when it receives a distance vector from a neighbor containing the different information than before. If a distance information is changed, suppose firstly the distance is from A to B is 7. Due to some reasons, now the distance becomes the 5. Only whenever the difference is there, then it can changes the information. Or secondly, it discovers that a link to a neighbor has gone down. Whenever a link is down, what it means, suppose a link is there from A to C and the value is 5. If this link is down, so it can update its table, so they can make the 0 value over there from A to C. Because a link is down, no packets can be followed on that particular route. Clear? Now we have an example of a distance vector routing. Now in this, consider three routers X, Y, and Z as shown in the figure. Each router have their routing table. Every routing table will contain the distance to the destination nodes. Now we have the three routers. Now look at here. X is there, Y is there, Z is there. Now let's start from X. Now look at this. First write the three values X, Y, Z, and again write the three values X, Y, and Z. X, what is the distance from X to X? Automatically 0. X to X, same destination, same center, same receiver, the value is 0. Now Y is there. What is the difference between X and Y? Look at here. X is there, Y is there. Now the value is 1. So they have the, from X to Y, they have the value 1. Now they have the X. What is the difference? Value is from X to Z. The 5 is written in the table. Now check the value. X is there, Z is there, value is 5 is there. So what it means, the complete distance from one router to the another router, that is mentioned in the table. So same can be happen in the Y table. Look at here. From Y is there and X is there. From Y to X, the value is 1. Where is Y? The Y is there, X is there, the value 1 is there. Y to Y means same center, same receiver, the value is 0. Now Z is there, Y is there. From Y to Z2, look at here, Y is there, Z is there, the value is 2. So automatically the values 1, 2, 5, and 0. 1 is from X to Y, or you can say Y to X. 5 is from X to Z, or you can say Z to X. And value 2 is from Y to Z, and automatically you send Z to X. So these three values and a value is 0. Why the 0? Because from source to destination, if the points are same, these four values can be the part of every table. You can write here. Look at here. Look at the X table 0, 1, 5. Y table 1, 0, 2. Z table 5, 2, 0. So what it means, each router, they have the information of the distance of the other routers. Clear? Now consider this next example. Consider router X. X will share the routing table to the neighbors, and neighbors will share it routing table to the X. And the distance from node X to the destination will be calculated. It's very simple. Whenever we are moving to the next node, we are considering the address, we are considering that particular distance, and again we are considering the next distance, and the value will be updated. As we can see, the distance will be less going from X to Z when Y is intermediate, so it will be updated in the routing table. Now if you are moving, if you are choosing the alternate path and the distance is less, on that condition you can update the value. Now look at here, from X to Z, the value is 5. Now, where is X? Now look at there. X is this, Z is this. The value is 5. But now why it write 3? It follow the path from X to Y, Y to Z. What is the value from X to Y? 1. And Y to Z is 2. So 1 plus 2 is 3. And 3 is less than 5. So in this case, they can update the value of this table. If the value is updated, or if the you are using the different root and the value of this particular root is less than to the value of the other root, then simply you can update the value. Again, similarly for Z also. Now what is the X? And look at here, from Z to X the value is 5 is there. Where is Z? It is a Z. X is this value is 5. But here they can cross the 5, they can write 3. Why are they 3? They follow the path from Z to Y. First you go to Z to Y, the value is 2. Then from Y to X the value is 1. 2 plus 1 3, and value 3 is less than of 5, so it can update the table. Now they have the new tables. Now you can write the 3 instead of 5, and you have to make all the tables. Why the 3 is there? Because they are choosing the alternate path, and in this path the value is less than as compared to the previous value, so the new tables are updated and they contain the latest value. Clear? This is all about the distance vector. Now we have the advantages and disadvantages. First is advantages. It is simpler to configure and maintain than a link state routing. All right, so the advantage is it's very simple to configure and maintain the link. Why? Because you can simply calculate the value, and whenever you have the value, you can write the value into the vector table is also there. So they have the number of disadvantages. The first, it is slower to converge that link state. Yes, to converting the link, the value of converge that link state is slower. Why the slower? Because it has to calculate all the different roots value. Suppose the 3 roots are from sender to receiver are there. First it can calculate the value of first root, then value of second root, then value of third root. Now it calculate all the 3 values, which is smaller, they can update into the table. That's why it is slower. Second, it is at risk from count to infinity problem. Yes, whenever the values count to infinity, what it means? It means suppose you have a table from where no direct link from A to Z is there. No direct link means first you have to follow from A to Y, then Y to Z is there. So what it means, you at that A point, you only have the value from A to Y, but you cannot have the value from Y to Z. So in A's table, from A to Z, you can write the infinity because you don't have the direct connection between A to Z. Yeah. It creates more traffic than the link state, since a hop count changes must be propagated to the all routers and procedures on each route. Automatically, it creates a more traffic. The more traffic can be converted from single route to the other route, and the number of hop counts are changes. How the number of hop counts are changes? Whenever you can change the path, the number of hoops are changes. So this is also another disadvantage. And the last one is for larger network, distance vector routing resulting in larger network tables than the link state, since each router must know about all the other routers. This can also lead to configure on WAN links, that is wide area network. It is not that very much okay with the wide area networks, because in the case of wide area networks, we have the number of systems are there. If the number of systems are large, so it's not easy to maintain each vector, and the no direct links are there. If no direct links are there, so we cannot easily calculate the values from a single router to the all other routers. It's very simple to calculate the value of the routers from a single router to the other router if they are directly linked with each other. If they are not directly linked, some other hoops are in between them, then it's very difficult for that particular system of the router to calculate the distance of other routers. So this is all about the distance vector routing.